Good morning, everyone. Today, I will just discussing few questions which generally comes in the often appears in the competitive exams and all. It will be a basic question session, like question answers, like on few topics. It will mainly deal with your food chemistry. Okay, just few basic questions which often we encounter when we are attending any interview or any kind of competitive exams. So we'll deal with that. First thing, I would like to say we often read a lot of books, maybe for food chemistry or going Shakuntala Manai, it can be Fenema, it can be Shivasankar, B. Shivashankar. Okay. Now, what exactly happens? We often have a lot of notes and every material is available, but still we, at one point, we forget the minute things. I have just figured out and clubbed few questions here, which I feel will be beneficial. You may follow it. It may not bore you to that extent. You can just take the questions and the basic concepts, and that will be fine. And this lecture is intended to all the students, mainly for the diploma as well as the UG food technologists and food engineers as well as the food science background. Basically, this will deal with food chemistry. So the first question is related to you are aware of the protein structure. Is it okay? So we are aware of the protein structure. So based on this, we will have a question. Protein structure is mainly having primary, secondary, tertiary, and quaternary structure. This is the basic which we are often come across in our first year, second semester, or third semester in biochemistry or food chemistry courses, which are mainly designed for food technology or food engineering. Okay, so even in plus 2 also some biochemistry parts will have this type of small details like protein structure. So here we know that these are the four structures available. Now we have two types of mechanism here. One is hydrolysis and one is denaturation. Often it's a hot favorite question for the examiner or the interviewer to ask a difference between this. What is the basic idea here? The primary structure is mainly made up of amino acids or peptides. Okay, I'll just brief here. Amino acids and or peptides linked by a peptide link. It will be a peptide linkage. Secondary ones will be having the alpha and the beta pleated sheets. I'm just giving a brief here. Okay. So if you then the tertiary as a tertiary structure followed by the quaternary, that is a folded coil structure of the proteins. Okay. Now, what is the basic difference between hydrolysis of protein as well as denaturation of protein? This is a very common question often asked. What happens? Denaturation is nothing but the uncoiling of the protein strands, okay, and it is giving you into subunits like tertiary, secondary, and primary. Like that, it happens for the denaturation of protein. And usually, it can be a reversible case also. Some cases, the denaturation is reversible, okay. Whereas if you talk about hydrolysis, and one more thing, denaturation of protein doesn't affect the main peptide bond, okay. Hydrolysis will be doing what? When the protein gets hydrolyzed, so it will be affecting the main peptide bond and you will be getting amino acids and peptides. It gets hydrolyzed into amino acids and peptides. Okay. So the basic structure that it affects the primary structure of the amino acids and peptides gets hydrolyzed into this subunits. Whereas the uncoiling or unfolding of the structure of proteins into tertiary or secondary, yes, tertiary secondary, that will lead to your denaturation of protein. So in a way, if I can modify the my sentence, I can tell you that denaturation. See, denaturation will bring it makes the peptide bonds of the protein readily available. It will be available as well as what happens. It is the modification or uncoiling. Denaturation results in uncoiling of the proteins, that is secondary, tertiary, and quaternary structure, and they do not break the covalent bonds. Covalent bonds they won't act on. The denaturation is not breaking or not affecting the covalent bond. This is what is the idea. Okay, excluding the breakage of the covalent bond. It is a process by which mainly it will involve the denaturation process, or the mechanism involves the hydrogen bond, the hydrophobic interactions. Okay, sorry, the hydrophobic interactions, and the protein completely will unfold. As I said, the uncoiling of the quaternary structure, tertiary. The bonds involved are hydrogen bonds as well as your hydrophobic interactions. Yes, and the protein molecules readily. Then what happens? The unfolding of the structure means the proteins will come together readily and forms aggregate. That is called coagulation, or it coagulates. Okay. Whereas hydrolysis will be usually uh, it breaks, or it will be by proteolytic enzymes, which gives you amino acids and peptides. This is the basic difference between the denaturation of protein as well as your hydrolysis of proteins. Is it okay? So the next thing what we will be talking about is, so I'll just club it again. So the first question was regarding the difference between the hydrolysis of protein and denaturation. If that is the case, what all are the basic points? The denaturation, if you are to hydrolysis, mainly is affecting the primary structure of the protein. It will be by the proteinase enzyme, and they will affect they will hydrolyze the proteins into amino acids and peptides. I will once again write it for your clear understanding. So the first question which we dealt with, the first question what I dealt with is denaturation. And the other one is hydrolysis. This is what this is here. So it mainly affects the hydrogen bond and hydrophobic. If you are talking in terms of bond, okay. If you are talking in terms of hydrolysis, we mainly go for this one as the main peptide bond gets distorted here. So peptide bond will get distorted. It will be giving you the amino acid, the entire unit peptides. Okay. The proteins will get hydrolyzed into that. Whereas for denaturation, it is uncoiling of the structure of protein, mainly with the secondary, tertiary. They uncoil it. But the hydrolysis mainly deals with the primary. Okay. I have a small question. You can find out when the egg is getting boiled, what type of mechanism takes place there? Is it denaturation or is it hydrolysis? Egg is getting boiled, whether it is denaturation or whether it is hydrolysis. That part you can just figure out once. It will be easy for you. to identify. That is a practical application you can take. Boiling an egg. Is it is it falls under denaturation or is it falls under hydrolysis of proteins? This is a small task which you can find out and see how it is correlating with the definitions what we have discussed now. The another few questions we have here is very simple but basic. The second question we will be dealing with is hydrolytic rancidity in milk. Hydrolytic rancidity in milk is due to what? Often we say it is because of the myristic acid alone, that is C4. But it is the C4 to C12 saturated fatty acids are responsible for the hydrolytic rancidity in milk. Next, third question which we will discuss is, we are getting the flavor, hydrolytic rancidity. The flavor often is rancid. That is because of mainly C4, but in the broader aspect, it is C4 to C12. Third is, when it is lipolysis takes place, the smoke point of oil usually will be, what happens when the lipolysis takes place? This is the topic of rancidity. Okay. So in rancidity, we will be dealing with a few main discussion. You will have questions on rancidity also. So the main questions what comes is, what are the two types of rancidity? Okay, and what are the mechanism of that? One is the hydrolytic rancidity. Another one is the auto-oxidation. That is lipolytic rancidity or auto-oxidation, you can say. Lipolysis, lipolytic rancidity or hydrolytic rancidity. Another one is oxidation. Okay. So if we are, you need to have a little concept about that. So in that, I have taken one point, that is, if the smoke point of oil usually decreases when there is lipolysis taking place. Okay. That means what happens? That means the smoke point, if it is the quality, obviously it is degrading the quality. If the smoke point is getting depressed, I mean, it is getting decreased, then definitely the quality of the oil is getting decreased. Here, this part, you need to know the concept of rancidity. For question 2 and 3, the rancidity part is important. Similarly, if I am talking about the another part which you have to know is, over here, when these questions are coming, you please try to go with the topic, what is lipolytic or hydrolytic rancidity. Okay, that is nothing but lipolytic or hydrolytic. This is one. And number 2, we can discuss, that is about oxidation. So oxidation usually is having initiation, propagation, and termination. So initiation, propagation, termination. So initially what is happening, how the free radical mechanism takes place, this part you can study for oxidation part here. What does the, like when you are talking about one hydrocarbon is there, that is trying to move the hydrogen atom from here and becomes a free radical. Similarly, the oxygen is taking that, you're getting to a diradical. That concept you should have a thorough knowledge about. Okay. So I have taken and I told what you have to do here. So 2-3 questions from this one has been taken. So read about rancidity. It's an important topic. Why it is happening? What is the basic difference between hydrolytic rancidity and lipolytic rancidity? And 2 questions. Why, if there is a rancid flavor in milk, why it is so? if the lipolysis takes place in oil, what does it what happens to the oil? That has been taken. Okay. Then next we will be having the fourth. This was the second part. So next the fourth question we will be dealing with. That is if you ask for a natural antioxidant, what is an example? Definitely, you can put it as natural antioxidant. You can have an answer like ascorbic acid we can use. Even sometimes they say even vitamin E. Ascorbic acid we can use as natural antioxidant. In addition to the this answer, if it is a synthetic example of a synthetic antioxidant, you can say TBH. You can say TB. Right. Right. Okay. Then we know about phospholipids. From there, if you have, maybe you know about what is phospholipid, what is lecithin, all these. Similarly, one important question you will have that egg yolk is rich in lecithin. This is one of the phospholipids. So this is one heading. This is an important question often you will get. So here the reference is you study about the phospholipids. When you are studying this, you need to concentrate on few, like on what is it mainly rich in, like that. So this is one question. Next is like egg white. Egg white will have one protein. Okay, egg white is basically having an overmucoid, and that is not coagulated by heat. Okay, so when you are studying about this, I'm giving you the tips what you have to do. When you are studying about proteins, then do study about the milk protein, egg proteins mainly, because they are rich in protein. What is the processing taking place? So that part you can cover up with this. So a protein which is not coagulated by heat, you can say egg white if the option is egg white, or you can directly mention this as overmucoid. Okay. Seventh question. Seventh question is milk is having protein. We all are aware that milk is rich in protein content. But what is the percentage of the protein? This is a very often question in a dairy industry interview you have. So milk is having two types of protein. One is the insoluble one, which is nothing but called as casein, and that constitutes 80% of the milk. Another is the soluble one, which is nothing but whey, and that is having around 20%. So we can say that this is about the milk protein. Okay, then eighth one. Eighth question we will be coming with, that is about, we are aware of the vitamins. So carry on, just study about the structures of the vitamin. Vitamin A is an alcohol. It has come after the name of term retinol, right? So that this is one answer. This is one point. So when you are studying about the vitamins, do study the structure and some common rich sources and the defective disease, the defects or the deficiency disease you are getting. Next, we are having beta carotene. Beta carotene usually will give you 2 mole of, that is 2 molecules of vitamin A. This is also a favorite question which usually comes. Okay. So till now we have discussed around 9 questions. So in the 9 questions, it's like about the hydrolysis denaturation of protein, the first one. Second goes with the rancidity part, hydrolytic, and what is the basic constituent or that causes flavor of that is rancid flavor in the milk. What happens to the oil if it undergoes lipolysis? The entire topic of rancidity can be taken into hydrolytic rancidity or lipolytic along with oxidation. You need to know what are the types because it's an important question often asked in exams as well as interviews and all. Then you will be having about, we will talk about example of a natural antioxidant. Then some like phospholipids, what is the basic main phospholipids and what is it rich in? So that has to be done. Okay. Then the next point which will be dealing with is milk protein. What is the milk protein consisting of? And what is like if you are talking about uh, the next part is vitamin A and beta carotene. Okay. Then we will come to the next questions. That is from 10. Just a second. So the next question which we can deal is with the 10th question. 10th question will be like, we often say milk is a complete food. Milk is an incomplete food. Why? What is the reason? This can be a this question, or even we can say milk is devoid of two components, or milk is a rich source of calcium, but it is not a good source of dash. What is that? The immediate answer what you will be having is vitamin C. Yes. Along with that, what else? So it is poor or vitamin C. Milk is a rich source of calcium and poor source of vitamin C. Along with that, you have to tell another point is iron. Okay. So if they say or another way we can say the mineral which is milk is devoid of mineral. What is it? Iron. So this way the questions may come. So you must be prepared in all way. Okay. So milk, the protein and the vitamin which is the mineral and the vitamin on which is devoid as well as okay, the mineral and the vitamin which is devoid of, so that you can take. So milk is basically a poor source of vitamin C as well as iron. It is a rich source of calcium. Okay, like that. Next, the next question is polyphenols in tea. You may be aware of the polyphenols in tea. What are the polyphenols in tea we have? Polyphenols in tea. What are the polyphenols in tea we have? That is catechin and gallocatechin. Okay, this is one. Then the next is around, we can say that dash is a oligosaccharide, or rather we can even say disaccharide, which is having galactose, which is at one galactose residue attached with sucrose. What is the example of that? It is nothing but raffinose. Same thing which will be coming over here is, if the galactose residue is 2, then what is the enzyme, what is the, if the galactose ratio is 2, then it will be called as stipose. Is it okay? Raffinose will be 1 galactose residue plus sucrose, and the stipose will have 2 galactose residues with sucrose. Then the next thing what we will be talking is these are may appear very simple and it may be a question why this many simple questions, but yes, sometimes it doesn't click at the right place. So you can go through this. I'm sure it will help you in one or the other point of. Okay. Then one more question will be coming here. That is the 12th question. We know about caramelization. So study about caramelization, study about browning. Okay. So here my question will be rate of caramelization. That means which sugar or yes. So which one will go fast, like the first will be caramelized. So if we have, say suppose fructose, glucose, maltose, lactose, sucrose, all these. So if I have to say that which one, the rate of caramelization, okay, which will go first for caramelizing, that is fructose. First will come as fructose, followed by glucose, followed by lactose, followed by maltose, then sucrose. Okay, so this will be my trend. Usually this, like the first one which gets caramelized faster is fructose, then followed by glucose, lactose, maltose, and then this one sucrose. Even this has a caramelization temperature of around 180 degrees Celsius. Whereas for fructose, usually it is mentioned at 110 to 140. Some places or some books you will find as 150. But this 110, okay, 110 to 120 max, it is getting caramelized. Okay, so you can mention that. So in that case, what all you will know? What is caramelization? What is the rate of caramelization at, in order if you want to keep? What are the temperatures mainly for fructose, for maltose? So that part you can refer. Okay. Then what is browning? Browning will be of two types, enzymatic and non-enzymatic. Maillard reaction, caramelization, that one comes, and another one is with the enzymatic. Based on that, we have one question here. That is, based on that, we have one question here. That is, what is the question number 14? 14 deals with what do you understand? That is, we can say, we are aware that there is a substrate, there is an enzyme, okay, and there are some products. I mean, final, intermediate, and final product. So if I say it is about enzymatic browning, you will have often you will be reading with a chart. My point is, if you know the enzyme, the substrate, the intermediate product and the final product in this form way, you will be easily able to recollect. The substrate is nothing but tyrosine. Enzyme is nothing but polyphenol oxidase. Intermediate product is nothing but dopamine quinone. Okay, this will dopa, and this will give you some gluco compounds. Okay, and finally the final product you will get it as melanin. So this is a short way to remember way how you can remember basics. The tyrosine is the substrate, of enzyme is the PTO. Intermediate product is dopaquinone, and final product is melanin. In between, you will have another gluco compound in between dopa and melanin. So this is the 14th question. Okay. The basics can be clear there. Question. There is a biopreservative that is called NIS. That is mainly produced by what is the enzyme? What is the microorganism? Lactobacillus. Certain cases we have Lactococcus lactis. So if you are getting to happen to see this, so obviously you will be focusing on nisin and some microorganism that is responsible for nisin. Along with that, you can go for the structure also. The structure of nisin is usually 34 amino acids. Okay, as far as I remember now, 34 amino acids forms. So this part can be clicked off. Okay. So this one is acting as a biopreservative. A biopreservative example is nisin. And 2-3 microorganisms you should be aware of. Okay. Then another question is like dash is an antimicrobial, or you can say milk has an antimicrobial, antibacterial agent. And even you can say egg is also having. Egg and milk has. So what are the respective antibacterial agents they have? One is the lactoferrin. In this lactoferrin, you can have the lactoferrin system you can study. And another one over here is your lysosome. How does the lactoferrin system works? That you will be aware in the very part, you can know. So this can be taken. Selectively, few questions I have taken. So here. Okay. Then we'll have an example of endotoxin. If I say an example of your 16th question, example of endotoxin, you can have it as salmonella, so in that case you can got to know about the exotoxin too. You can study about the food spoilage, some microorganisms, as well as food toxins. Even there are some toxins which are present in mushroom. You can know that some toxins in mushrooms. Even you go for aflatoxin. Aflatoxin, usually they give a question from this. Okay. So with this, we stop the lecture here. Hope the session helps you. The lecture has been session, and I have by myself as a Gupta, Research Scholar, Department of Agriculture and Food Engineering, IIT Kharagpur. Thank you so much. See you in the next.